Okay, so today we're going to talk about rational functions. We're still in our polynomials chapter, so it seems kind of weird. But what happens is we have a fraction where the numerator is a polynomial and our denominator is a polynomial. So we're still working with polynomials, we're just working with them as a fraction. Okay? What do we call this dotted line right here? An asymptote, what kind? A vertical asymptote, and this one is a horizontal asymptote. Two very key features of a rational graph. Okay? So a rational function is written of this form. We have a numerator function divided by a denominator function that are polynomial. Okay. It is important that our numerator and denominator do not have any factors in common. So we are going to talk about that. It is important. It is important that we simplify first. Okay? We also know how to find the domain of a rational function. You did it in chapter 1. So the test, in fact. What do we have to look at? We have a fraction, and I asked you for the domain. We looked at one piece of our fraction. Which piece? Brainstorm real quick at your table. We cannot divide by 0. We don't want our denominator to be 0. And anywhere our denominator is 0, we cannot have it in our domain. It gets thrown out. Okay. We will also identify range, but we can't identify range all the time until the graph is in place. Sometimes we can do it before, but most times we'll just wait until we have the graph. Okay? Now, we're going to have two, potentially, we're going to have to identify a couple things. Okay, the first thing is a vertical asymptote. Okay? You saw it on that first slide. It is a vertical line. Is our graph going to touch it? No, but what's it going to do? Get closer and closer and closer and closer, okay? So I have written up here a vertical line where f of x increases or decreases without bound. Okay, don't use my words, use your words, okay? Our graph is going to approach the asymptote, but never touch it. Does anybody remember how we identify where the asymptotes are? Does anybody remember where they are? I'll give you a hint, we just talked about it. It's where our denominator is 0. It's at those places that we've excluded in our domain. Now, this will get a little less straightforward when we get to a certain situation here in the last part of class. But once we have simplified where our denominator is 0 is where we have vertical asymptotes. Okay? So we'll identify the vertical asymptote and plot it. We'll identify potentially a horizontal asymptote and plot it, and then we can pick points to fill in the rest. Okay. Horizontal asymptote, its definition is a horizontal line that f of x approaches towards infinity and negative infinity. Something that you might remember from Algebra 2, I'm not sure, but it is possible to cross a horizontal asymptote somewhere in the middle. That is okay. Vertical asymptote, no. Horizontal asymptote, yes. But as long as we approach it towards infinity, then we're good. Okay? There are 3 rules for horizontal asymptotes. There are 3 different situations that can happen. And they're all based on the degrees of the numerator and denominator. Whoops. Okay. So we are going to compare the degree of the numerator to the degree of the denominator to determine where our horizontal asymptote is. Okay, we're going to look at 2 of the 3 cases today and the 3rd case tomorrow. Because the 3rd case you did not talk about in Algebra 2. Okay? So our first case, when the degree of the numerator is smaller, then our asymptote is y equals 0. This means your denominator has a larger degree. And if your denominator continues to be larger and larger and larger and larger, and it grows faster than your numerator, then your fraction as a whole is going to shrink and shrink and shrink and shrink and shrink all the way to 0. So if the denominator has a larger degree, y equals 0, no matter what. However, if they're the same degree, anybody remember that one? It's really okay if you don't, but just before I show it to you. If they have the same degree, like they both have x squared as their highest degree, for example, then y equals the number, that's the ratio of the leading coefficients. Okay, so we look at both the leading coefficients to figure out what that is. Okay? So I'm going to put on the next slide just steps I want you to follow in the graph, okay? I know that some of us are really step-by-step kind of people, so I want you to have this in your notes for you to look back on as you're doing this, okay? So when we graph a rational function, you better factor both the numerator and the denominator in case you can simplify. Because one of the very first things that we talked about on our first slide is that our rational expression better be simplified. Okay, so go ahead and factor the numerator and denominator just in case. And you know what? If they don't simplify, that's okay. Because if they're factored, it's easier to determine your vertical asymptotes in the denominator. Okay. So after you factor and potentially simplify, I want you to identify, and I would just write VA for vertical asymptote. Determine and then sketch in your vertical asymptote. Write VA instead of vertical asymptote. It will save time and room on your paper. Okay? Then determine and sketch in your horizontal asymptote, HA. Save some time and room. Okay, we talked about 2 rules. Tomorrow we'll have a third. But if there's a horizontal asymptote, I want you to figure it out, draw it in. Okay, once you have your asymptotes, really the hard part is over. From there, it's plugging and chugging. We're going to choose x coordinates to plug in to find y coordinates and plot those on our graph. Okay? Your asymptotes are going to kind of split your graph into sections. Get at least 2 points per section so that you can figure out what your curve looks like. And then make sure you draw a smooth curve. There are no jagged edges. It's all very smooth. And we approach our asymptotes. And then we'll always determine domain and range. This is what I'm going to do. I have 3 examples, but I'm only going to have you write down 2 examples. The first example that I'm going to go through is a very, very basic example. It's one that you probably would have had on a test last year in Algebra 2 or Algebra 3, whichever class you came from. So I just, kind of as a warm-up, I just want you to watch me go through it. Okay, so everybody just put their pencils down once they have these 6 steps written. And we're just going to go through this example quick, okay? So, here we go. Can I simplify that fraction? Not at all. There's nothing to factor. There's nothing to cross out. This is as simplified as we can get. So the second thing, our vertical asymptote. Well, our denominator equals 0 at x equals. So my vertical asymptote is the line x equals 2. And we plot it. Okay. Our horizontal asymptote. The degree of our denominator. Same or bigger as the numerator. Our denominator has a bigger degree. So automatically our horizontal asymptote is at y equals 0.
Is it bigger because it has an x?
Right, so this is x to the first. This would be considered like x to the 0.
Okay.
Yep. Okay. If this were 3x, then we would say that they have the same degree. Okay? Thank you for asking. Okay, then you're going to set up an xy table. And your xy table is going to be based on where that vertical asymptote is. So our vertical asymptote is at 2. What are 2 numbers to the right of 2? Okay, those are good numbers to plug in then. When I plug in 3, I have 3 divided by 3 minus 2. If I plug in 4, I have 3 over 4 minus 2. Just 3 halves, right? Okay, we have 2 points, and we know that we have a smooth curve that should approach our asymptotes. What are 2 numbers on the other side of 2? 1 and 0. When I plug in 1, we get 3 over 1 minus 2. So that's, what, negative 3?
Yeah.
And then when we plug in 0, we have 3 over negative 2. Okay, we have 2 points. That's enough for us to know that we have a smooth curve that approaches our asymptotes. That's our graph. Questions on that before we find domain and range? "20 seconds. Just discuss with the person next to you. What do we exclude from our domain? What do we exclude from our range?"
And we need to exclude 0 from range.
Okay. Mia, what do we exclude from our domain? Okay, which is that? Okay, so our domain is going to be everything except 2 because we have a vertical asymptote at 2. Okay? Gracie, what do we exclude from our range? 0. What's that 0? Like, why are we excluding it? What's there? Okay, we have a horizontal asymptote there. Nothing's crossing it. So there's our range. Okay? Now that is a nice, straightforward, simple example. Let's look at 2 examples that are a little bit more involved. They're pre-calc examples, okay? They're not algebra 2 examples, they're pre-calc examples, okay? Write this one down. Okay. Is it possible to factor anywhere? Yeah, we can factor our denominator, right? We can factor our denominator to x minus 1, x plus 1. Now, can we simplify that at all? No. But we can factor the denominator, which will help us. Because the denominator tells us where what is. Well, where's our denominator equal to 0? Oh, 2 places. We have 2 vertical asymptotes. And because I know what this graph looks like, I'm going to go ahead and up here so you can get a better picture of what's going on. I'm going to count by halves. Okay? Okay. That'll just be easier for me. Okay? There we go. Now, the degrees of our denominator and numerator, they are the same. So when they are the same, we look at our coefficients. Our coefficients are 2 over 1. So our horizontal asymptote is y equals 2 over 1. I just read it.
So should we also graph it by 1/2, or should we graph it by 1?
Well, if you don't have a graph paper notebook, you can kind of space out your tick marks however much you need. So as long as you're spaced out a decent amount, you're fine to count by 1s. I am kind of stuck to what's up here. I want you to be able to see everything, so that's why I did this. Okay, at this point, okay, this is the most important part, okay, and it doesn't always take as long, but now we need to make an XY chart, okay? I'm kind of running out of room though. Let's do right here. So we have 2 vertical asymptotes, One of them is at x equals 1. So what are a couple numbers we can plug in to the right of 1?
2, 3.
Okay, let's keep it close and keep it nice with integers if possible. Okay? So when we plug in 2, 2 times 2 squared is
4 times 2, which is 8.
over 2 squared minus 1. So 8/3. So we have 2 8/3. Okay. What is 2 times 3 squared?
18.
Over 3 squared minus 1.
8.
And 18 over 8 would be the same as 9/4. Do you notice how I'm kind of making like some scratch work and then putting my number in my XY chart? Okay, that's okay to do. So let's see. 4. Okay. We have our two numbers. We know that's going to happen. Okay. On the other side, I want to go to this asymptote right here, which is at -1. Let's go ahead and plug in -2 and -3. Some of you are getting excited, right? Alrighty. If we take 2 times -2 squared,
That's 8.
positive 8, -2 squared
4,
minus 1.
3.
Huh. 8/3. That's kind of nice, isn't it? Okay. 2 times -3 squared would be 2 times a positive 9. And -3 squared would be 9 minus 1 is 8. So we again have 9/4. Connect your coordinates with a nice smooth curve approaching your asymptotes. Okay, now here's where it gets funky. I don't know if you remember from Algebra 2. There are two different things that can happen when you have two vertical asymptotes. You could snake all the way through, or you could turn around and kind of have a U shape in between. We don't really know. And so you probably need 3 points in between those two asymptotes so you can figure out, do we snake all the way through or do we turn around? Okay? So what's one number that we can pick?
0.
Oh, 0. Okay, 0 is a nice one to plug in. And when we plug in 0, we get 0 over -1, which is 0. Excellent. Okay, someone else suggested, well, we can plug in 1/2, right? Okay, well, what is 1/2 squared?
4.
Times 2.
1/2.
Okay. And then 1/2 squared, 1/4 minus 1. Uh-oh. And when we take 1/2 divided by -3/4, we end up with what? 1/2 times the reciprocal. What is that? -2/3. It's okay to make scratch work to get these values. Don't try to do it all in your head and then get yourself mixed up. But remember, this is a non-calculator test. Okay? All right, what's another number we can plug in so we know, does it snake or does it turn? What number should we plug in? Negative half. Okay, but that's okay. What's negative 1/2 squared? Times 2. Cool. And then negative 1/2 squared is 1/4 minus 1, negative 3/4. So yes, it's the same thing. Negative 2/3. So we know it makes a U, and as it U's, we have to approach our asymptote. Kind of a pretty graph. Okay. What can I clarify before we talk about domain and range? Okay. So our domain. We need to exclude a number or numbers from our domain. Kelly, what are those numbers?
1 and -1.
Okay, we need to exclude -1 and 1 from our domain. So we have to write 3 different intervals. Negative infinity to -1, because we're excluding -1, and then -1 to 1, because we're excluding 1, and then 1 to infinity. Now this is a graph. We will not be able to do the range until it's actually up here. So I need you to describe to me, where are our y values? First, they're above what?
2.
Okay, we have a horizontal asymptote at y equals 2, and do we have y values above there? Okay, do we hit 2? Okay, so we know we have values from 2 to infinity. Okay, and then we have values beginning where?
Negative infinity.
And stopping at?
0.
Do we have a value at 0?
Yes.
So we do have a value at 0, and then it goes below to negative infinity. So we have values all the way negative infinity, they stop at 0, and then we have values again above 2, and they keep going up. Okay, I would literally take your pencil and move it from the bottom to the top and figure out where your pencil is hitting y values to figure out where your range is. Okay, the horizontal asymptote, yes, will be a factor, but in a graph like this, there's more than just the horizontal asymptote to consider. Okay. All right. Ask me a question if you have one. Raise your hand if you remember graphing a graph sort of like this in the past. Like it's back there in your memory somewhere, like we needed to go through this, okay, but we've seen something like this, so it's not like, whoa, what's going on? Okay, so let's talk about our second pre-calc graph. Probably the more important of the 2 graphs. I said that really loud. Write this down. The more important of the 2 graphs. Okay, what is my first step?
Factor.
Who can tell me our numerator?
X plus 1. And then, wait, no. Yeah. X plus 2.
X plus 2, you're changing it to?
Yeah.
and x. Okay. Cool. Our denominator. X plus 2, x minus 3. We can cancel. Do you think that means something?
Yes.
Yeah, it does. It means something very special. You don't have to write this down quite yet. When factors cancel, it means there is a hole in our graph. So if you want to make a note somewhere, you can. But when factors cancel, there is a hole in our graph. So in this case, I'm going to write a note to myself. We have a hole at, since the x plus 2 factors canceled, x equals negative 2 is our hole. So we'll have to make sure we graph that. Okay? Now what we can do is we can use this simplified version to help us with the rest of the graph. Okay? So our factors canceled, which means there's a hole, and now we have a simplified version. So based on this simplified version, Sophie, where would our vertical asymptote be? Where our denominator is 0, x equals 3. And we'll graph it. Okay. The degrees. Same or different? Same. And since they're the same, we look at the leading coefficient. Our horizontal asymptote occurs at 1 over 1. Okay, so this looks very similar to the graph that I did at the very beginning of class, right? One vertical asymptote, one horizontal asymptote. So we know we're going to have two nice curves. The only difference is we're going to have a hole somewhere, okay? Yes?
How do you find the HN again?
The horizontal asymptote? So since the degree of the numerator and denominator are the same, we look at the coefficients in front of those. And since it's 1 over 1, our horizontal asymptote is at 1.
Oh, it's like that fraction.
Yep, it's the fraction. Kind of like over here we had the 2 over 1. Yep. Yep. Good question. Okay. So now let's plug in some values. Okay. Okay. Let's be strategic. What are going to be the values to the right of our asymptote that are the easiest to plug in? Okay, our vertical asymptote's at 3. Let's just pick integers just to the right. So 4 and 5. And let's work smarter, not harder. We simplified our fraction. It's going to be easier. You're going to get the same values, but it's going to be easier to plug into the simplified fraction. Look, 4 minus 1 over 4 minus 3. What is that?
3.
Oh, so much easier than 4 squared plus 4 minus 2 over 4 squared minus 4 minus 6. Blech. Too much work. Go to the simple. Okay, so 4, 3. Okay, and then when we plug in 5, we have 5 minus 1 over 5 minus 3. Oh, that's so nice. So nice. Okay. Now, on the other side, we need to plug in, looks like 2 and 1 would be right next to it, right? We have an asymptote at 3, then we can choose 2 and 1. Okay. So we have 2 minus 1 over 2 minus 3. Okay, so if I plug in 1, we get 1 minus 1, which is 0. Over it doesn't matter. I'm going to take a time out here. If I wasn't plugging in 1, how would I know that that was going to be an x-intercept? Okay, wherever your numerator is 0, that's going to be an x-intercept. Okay, so if you set your numerator equal to 0, those are x-intercepts. Where your denominator is equal to 0, those are your vertical asymptotes. Okay. Now, we can't make our curve yet because we need a hole. Our hole, and I'm going to label it in my graph so I don't forget about it, is at -2. Okay. -2 minus 1 over -2 minus 3. Our hole occurs at -2, and when I plug in, we get a y value of 3/5. So you need an open circle at -2 3/5, and now we can make our curve. Okay. I have 1 minute left, probably 2 minutes actually, so don't get in too much of a hurry. Okay, make sure you plug the x value in to figure out where your hole is to plot it. Our domain. We have 2 places that made our original denominator 0. We have to exclude both of them. We do not have anything at the hole, and we do not have anything at our asymptote. So both of those need to be excluded. The hole is empty, and then at 3 we have a vertical asymptote. Both are out of there for the domain. The range. Do we have a y value at 3/5? We have a hole right here. So just like in our domain, our range, we need to exclude the hole, or y, so the y value of the hole, and our horizontal asymptote. So -infinity to the hole at 3/5, and then 3/5 to the horizontal asymptote at 1. 1 to infinity. Ooh, we just made it. You have 7 problems. They're not all graphs, I don't think, though. Okay? You will have a graph on your quiz tomorrow. Yes, we will have time to ask questions at the beginning of class. Okay? But I need you to attempt all 7 problems in your homework. If they're odd, what do I expect you to do? Check your answers. Okay?